Here we have a 2020 MacBook Pro, the M1 version, A2338 model that came in for data recovery. Customer said that he spilled liquid on the laptop and he cares about the data more than the laptop. If we can fix both the laptop and get the data for the customer, that would be great. Otherwise, data is our main concern. We already have the motherboard out right here, and based on visual inspection, just by looking at the board, I do not see any signs of liquid, so I do not know what's going on. Let's go under the microscope. I mean, if the laptop suffered liquid damage, then we should be able to see signs of liquid somewhere on the board. What if the problem is the keyboard, the touchpad? We already disconnected the keyboard and touchpad and was not able to power the laptop on. Oh, look at this. Look at this area. Look at those caps. One end of the cap does not look good. My guess is liquid hit this area here. I mean, we see a lot of discolored components here, capacitors, and we're going to have to measure those caps to make sure we do not have a short circuit. Let me continue with visual inspection and then we can come back to this area. But this area has a question mark over it. If all caps checks out good, then we're going to assume the area is good, even though we have some discolored caps. Look at this. I see signs of corrosion here, but nothing major. Anti-glare light on, and we get rid of all the reflections. And where do we buy the anti-glare light? Just log into NorthridgeFix.com, click on shop, and you can buy it from there, along with this amazing microscope, the ring light, articulating arm, genuine Amtech Flux, hot air station, soldering station, charging stations, power supplies, multimeter, probes, tweezers, grinding pen, everything. We have all items in stock, and orders almost always ship out same day. Our stock has increased exponentially since we got the warehouse, and all items are in stock. So I do not see anything other than what I noticed here. And look at the difference between having anti-glare and not having anti-glare. You see a different view, a totally different view with the ring light compared to anti-glare light. And that's what I like. I want to be able to see what I'm doing from different perspectives, different light angles. I mean, this white stuff here was not visible using the ring light, but is visible with the anti-glare light. Let's measure some caps in diode mode. We do not have a short. We do not have a short. This must be ground. We do not have a short. 0.3 voltage drop. That's good. And we do not have a dead short here. Low resistance. Let me go to resistance mode. 32 ohms. That's not a dead short. Let's measure the components in question, like this one here. It's reading good, high value. We have a high value here, and ground is here. What about this one? 0 ohms. And 0 ohms. Okay. So we have it that short on this cap here. What about this one? 0 ohms and 0 ohms. So those two must be connecting to the same line, and one of them must be affecting the other. This one is 0.2 ohms and 0 ohms here. Those two are that short. What if we go, you know what, let me go back to diode mode so you can hear the beep. See? And the short is extending all the way to those components here. Go back to ohms mode. 0 ohm. And the same here. So we have 0 ohms on all those components here. But those caps, they look good. The ones that do not look good are those two. And this one. But this one is reading slightly higher than this. 0.2 ohms rather than 0. I'm going to keep my focus on those two components for now. Why don't we blindly remove one of those two components? We can use a thermal camera to possibly pinpoint where the short is coming from, but let's try it this way. Let's try to randomly remove one of those two and see if we can get rid of the short. Let's start by removing this cap and see if that will change anything. Fume extractor on. And let's see, do we still have a short? Is it our lucky day? Meter in diode mode. And we're gonna measure right here. And look at this, we do not have a short anymore. I'm reading 0.3 voltage drop. Ground should be here. And wow. The first cap I removed the short. What a lucky guess. Let me check the cap next to it. 0.3 voltage drop. 0.3. 0.29. 0.29. Right now the board is hot. As the temperature cools down, the reading will be higher. Should be around 0.4, 0.5. But right now we are reading 0.31. Wow, we got it. We got it. And if we measure this capacitor that we removed in continuity mode, is it continuous from here to here? And you see, look at this. The cap is bad. Let's completely remove this cap. I'm gonna hand over the board to Big Boss to reassemble and test, and I'll be back to finish the video. Hopefully, removing that short will solve the problem. Good. Yes. Yes. The laptop is fixed. Look at this. It's booting up. And one tiny capacitor that was short into ground was causing the laptop not to turn on. Amazing. Wow. Wow. The boss of all bosses. All the time. 100%.